Generative agent systems use AI to create somewhat realistic, somewhat autonomous characters that attempt to mimic human behavior, act on their own, and can technically collaborate with each other to achieve a common goal. And just recently, Microsoft published a library, a Python library, TinyTroupe, that uses AI to create multiple agents with their own personalities, interests, characteristics, and those agents are supposed to work together in a business context to achieve a common mission. And since I've spent a lot of time during the past months trying to generate agent behavior and reading all the nonsense communications they produce, I was really curious how Microsoft approaches the agent personality, their memories, and a lot of other questions. So let's look at this library together. In the GitHub repository, in its README file, you will find a lot of useful information on the library, including the use cases it was designed for, and the creators of the library recommend to use it for productivity and business scenarios. And this is quite ambitious, I admit, because we know that agents can produce a lot of nonsense and kind of go all different directions, and sometimes even though they do mimic well human behavior to some extent, but still you can often spot the difference between an agent and real humans. There is some kind of a bias which agents usually bring, and when you spend a lot of time with agents, you can clearly see some tendencies in the way how they communicate. But anyway, so this library, it actually focuses on those productivity and business scenarios. So we are taking whatever agents say here seriously. And it can be used for advertisement, software testing, brainstorming, a lot of different use cases with data. So there are some examples, and we will look at them in a second. To install it, you can either do it locally, and there are some instructions. Disclaimer, I am not a Python developer. I am a JavaScript developer. So Python thing is a bit of a mess for me, so I decided to use a GitHub code spaces and run the code here. We have a configuration file over here. There are actually two of them, and not to get confused. One is in example folder, another one in TinyTroupe folder. I kind of think that there should be only one, but that's a minor thing. So in the configuration file, you can technically change the model. By default, the model which is used is GPT-4o. Because I was running the examples multiple times, I was also debugging. I had some issues using the OpenAI token, and that's why I was like, okay, I will switch to GPT-4o mini for the sake that I don't spend a lot of money. But generally, after running all of that, I think that neither of the scenarios bring a lot of conversations between the agents, so eventually the conversation stops, so you are not in a danger of losing a lot of money and going into infinite loops with those agents. So don't worry, this will not bankrupt you. And I think that actually they have in the code, they prevent those infinite loops of agents talking over and over the same thing again. So that's actually also quite helpful. So this is the configuration file. You will also need to use either OpenAI or Azure, and I was using OpenAI. In the .env, there is .env local. You will have to rename it to just .env or use whatever approach you are using. So I put here my OpenAI token, and then I had to install python.env library and include that information from the .env file additionally before I start running the code. So yes, so and then you have a lot of different examples here which you can try out and see the library from different perspectives, because you can cover different scenarios with it. So for example, one of those scenarios is creating an advertisement for apartments. So we have a group of people, potentially friends, I have no idea, and we create like a focus group Actually, true, it's not friends because it's a business use case, right? So it's a focus group between Lisa, the data scientist, Oscar, the architect, and Marcus, the physician. And one of them needs an apartment that they must rent, and they want to create an advertisement for that. So they have a conversation, and I'm sorry for these things. It was debugging, my way of debugging Python code, and then there is a conversation going. And in the end, they come up with a good idea for advertisement, and they even create a proposal, like not proposal, but advertisement text, which they can use later to publish somewhere. So I was thinking that advertisement is pretty boring, to be honest. And to be honest, I really don't like advertisements in general. So together with my trusted advisor ChatGPT, we try to come up with something a bit more interesting, humorous, and sadly we didn't come up with anything really good. However, the scenario which I took is kind of creating the guidelines for desk decorations. And here my idea was that if I will have characters who have different approaches to their preferences to what should be on the desk and how many things they want to keep, and they need to align and agree on some kind of desk decoration rule for the office, then I might see some conflict there. We'll see how it went. So for this, and let me just clear all outputs. And for this I created, well, actually let's go one by one, step by step. So first we will run, and I will select the Python library here. So the first is just set up steps. So here it just outputs what we are going to use, all the stuff. I didn't really try to change temperature. That would be also nice to experiment. And here I'm using the GPT-4o mini. Here we are creating next the focus group, and I created several additional characters because I decided that Lisa, the scientist, and the rest, they have a bit more generic descriptions, and I wanted to have people in my focus group who have different opinions, so that I would see somewhat a conflict based on their conversation. So I have Ray, the project manager. Actually, Ray is the most boring person out of them. So let me scroll to Ethan. So Ethan really likes a tidy place. And actually, this is ChatGPT. That's I blame ChatGPT for this a bit of a gender bias here. Probably I should have changed, but sorry, didn't. So Ethan has preference for clean desk. He is extremely practical, avoid unnecessary frills, whatever frills means. So the whole idea is he really likes cleanliness and little things. Maya, on the opposite, likes a lot of things and really is creative. He finds joy in impulsive decisions and so on. So I kind of expected that Maya would be fighting for more things on her table, versus Ethan will be like, nah, we should kind of limit it to the minimalistic style. And then Ray is a totally different personality out of those two. So then to create the focus group, we use the tiny world. I have an error here. Let me see what happened. Agent name is already in use. I think I'm already run it once. That's why it gives me this error. Okay, so I think it's good. So then, situation. The focus group must define the official guidelines for desk decorations. I also added this line: the participants suspect that they are not aligned on their preferences for the office decor. I really tried to sneak some kind of a conflict there, just to see how the whole focus group works. It's also kind of a bit sad when everyone agrees with everyone for the conversation. It just like doesn't have much of a variety in that case. So we create those things, and then we broadcast that situation and task and whatever else we have to our agents. And then we start the discussion between them, and this is where interesting things happen. So here you will see different types of produced messages. For example, there is a mix between thought and talk. So each of the agents have this moment where they kind of indicate that they are going to act for some time, and when they are done, they will indicate that they are done. So the process is kind of waiting, I guess. And here we can see that the Ray started with kind of that message, and then he produced a phrase for other agents and said that they should consider a few key points for the guidelines. And after that, he's like, I'm done. Then the information is sent to Maya and Ethan, and therefore this is marked as conversation. Not exactly, I think it's kind of a bit confusing, the word conversation, but this means that Maya and Ethan actually accepted that message from Ray. And then Maya starts her round, and she said that she completely agrees with Ray, and then she also wants to set the maximum number of items. And the conversation goes in this manner where every of the characters has a space to say what they want, and they exchange and they process, or like not process, actually they react to the messages of other people. You can also notice this focus group step 2 of 3. And this is where I believe, because I suggested 3 items here, 3 goals. Maximum number of items allowed to define, types of items that are permitted, and rules for sentiment versus aesthetic decor. So the agents go through all these 3 items. And I think it's actually pretty nice because here we can have this separation between those steps. I'm not sure how much this actually mimics the behavior of humans because we are a bit more chaotic with our thinking. There are some other considerations which I have, and I will share those later regarding this whole conversation. But at the end, they all agree. And they covered all 3 points, and they came up with decisions for all those questions, parts of the common goal to define this guideline. And after this, what we can do, what at least the example suggested, is to create a file, a guidelines, to compose this file for guidelines for desk decorations based on the discussed ideas. So if you run this one, then the information in their memories, which they have, will be processed, and then they will create some kind of a rules file. And then we can save that file and find it later in the extraction. Here it is. So maximum number of items. Set a maximum number of items to keep the workspace organized. This is a bit, I think, not exactly a good answer because they didn't really decide on the final number of items. Types of items encourage personal touches that reflect personalities. It's quite vague, I would say. Allow 1 or 2 sentimental items. This is okay, at least somewhat specific, and the rest. So this is one of the examples for which the library can be used. You can check other examples. For example, you can generate synthetic data, you can do some kind of brainstorming session and the rest, but you got the idea. Now let's look into the code a bit and what is outstanding here in the code. So in the main file, so agent.python is the main file, pretty long. Is it normal for Python to have like over almost 2,000 lines in the code? I would be not allowed to submit such things to JavaScript. Anyway, so here we have an agent class, or actually like tiny person. So it's like tiny person and tiny world. So tiny person is for an agent with all kind of characteristics of the agent. You can actually see the place where I created, here it is. When we create Maya, and we say, okay, we would like to have a tiny person Maya, and then we define the characteristics of Maya. Those characteristics, by the way, here they're used as a text, but they are fixed properties, which is also a bit confusing. But if, for example, I will search for personality traits, I can find that we use those personality traits later in the prompts. So here, like, there is a number of files with prompts for that agent, and we use those different characteristics of the agents to build those prompts to send those requests to large language model. Another very important method in the class of agent is method to act. One of the most important building blocks defining the next action of the agent, taking into account the current circumstances. And if you go a bit of a level higher in the class tiny world, which defines environment for the agents where we put those agents, and then that environment controls the interaction between the agents. So here we have the method step, which is kind of a single step in this environment lifecycle. And here we iterate over our agents and we let each agent to act. And then we handle the actions. So during the action, actually agent can perform either the necessary number of actions to achieve a certain goal, or we can limit those actions by some particular number of them. Also, during the action state, what we do here, we update the internal cognitive state of the agent. So here, actually, if I would find that method, it doesn't do some reflection stage, which I expected at first that there should be some reflection stage from the agent after the agent learns something new, but no, we just seems to update here the latest goals, context, attention, and emotions, which actually, in my opinion, might be a limiting factor. So if we look at the flow of the conversation which we have seen when our agents were creating this guideline for the desk policy, what happens is that when an agent produces a message, for example, Maya produces some message to the other agents take that message and they kind of consume it. But what I'm missing here is that Ray and Ethan will do a kind of a reflection on what Maya had said, so that information changes their future behavior, so they have a bit more like processing of the message. So the thing is, when we as human beings discuss something or debate about something, we do this reflection about what other person tells us. And this is what I am missing here. Here is mostly like reacting to the phrase instead of internalizing, thinking about it, and then giving the best judgment, especially when the opinions are different. So this is at least how when I was working with agents, this is where I'm trying also to make this reflection stage, which also relies a bit on large language model to process and to create new thoughts based on the personality of the agent and what they currently are listening to, and maybe the whole conversation flow. But anyway, so we have this ACT method. We also have a lot of useful other methods here, such as listen, important, socialize, see, think, internalize goals, observe, and other methods. So there is a good framework for the agent behavior over here. What I also liked when looking for the ACT method is that there is an attempt to prevent the hallucinations by by repeating the request to large language model. At least I saw this here, that in the comments occasionally the model will return JSON missing important keys, so we just ask it to try again. So because models can really retrieve us information in the format we don't expect, and you can also like experiment, and when you're making like hundreds and thousands of requests to large language model, and even if your prompt is really good, occasionally it will mess up and tries to be very creative, and then we need to retrieve that information again, hoping that this time model will not mess up. So I think this is a good approach, and this is something which I actually don't do in my project, and I'm going to borrow this idea and try to anticipate wrong response and then call the model again if I'm not satisfied with that. Some other interesting things involve memory here. So if I would look for a memory, episodic memory, we have two types of memories, semantic and episodic. So semantic memory, and by the name it is based on vector search, and we do have the reference to the embedding model in the configuration. So here we are using text embedding 3 small. So the memories then are indexed into the vectors, and then we can use a similarity or semantic search to retrieve those. So this semantic memory is memory of meanings, understandings, or other concept-based knowledge unrelated to specific experiences. Then we do have another type of memory, which is the episodic memory. It is cognitively episodic memory is the ability to remember specific events or episode in the past. To be honest, for me, this sounds somewhat confusing, because how I would distinguish the memories is the memory of the current moment, or like the short memory, and the long-term memory from the past, where events can be a bit blurry, as it's where I think like semantic memory kind of is a good one, because then we can retrieve parts of it, but we know that most probably we actually not retrieving everything, and this resembles a human being with our imperfect memories from the past. And even though I would have done it, or I did it differently, to be honest, with the memory, I need to look into this, because maybe they actually have better results by separating it in this episodic and semantic memory, and having a bit of a different approach to separating different types of memories which agents have. Also, if we have a more complex scenario involving agents, where agents, let's say, meet not only once as a group, but they have a regular meetings, and then the future interactions should be actually reflecting what happened and what discussions and decisions were made in the past, then we might run into issues with the context window, and that will be interesting also to see how exactly the current approach handles it. Apart from all the building blocks for the agent, for the memory, behavior, and so on, and also the environment where the agents are, there are tons of small tools which can help you create those agents. For example, there is the Tiny Person Factory, which allows producing, let me find this, Tiny Person Factory, which allows to create a tiny person without specifying all the properties manually, so it will generate all that information about the agent through the large language model. I think we can see it actually in the prompts, and additional appreciation for the prompts, because prompts are, I mean, prompts is just text, but it's quite difficult to write good prompts for the agents so that they kind of perform step-by-step actions, and it's very nice to see how other people do it. And I think here they kind of found a really good way, because when I was playing, at least I didn't see very obvious hallucinations from the agents, or at least like they were following normal discussion and not giving some random stuff or like information which is not well structured. Because sometimes for me the agents they might start, or like the large language model will start including some additional symbols indicating the conversation, or like putting the thoughts into the conversation, or at least Claude likes to do that. But here I think it was quite clean response from agent to agent, which I really appreciated, and I will look more into the prompts. Talking about hallucinations, what I noticed in the comments is that they perform this thinking, I will act a bit and then issue done. So they have a comment over here that this seems to help better model responses, perhaps because it interleaves user with assistant messages. So this is also quite interesting and might be a good approach to overcome that misbehavior from the large language model. I will definitely give it a try in my projects. So all in all, I really loved playing with this library, appreciated all the work which the creators of the library put into it. It's not groundbreaking stuff, obviously, however, it's still quite helpful to see how other people tackle these challenges. Some of the things which I would love to see more here is the ability to create this conflict where we can kind of see that agents disagree with each other. Because through disagreement we can find better solutions, and especially if this library is positioned to help with business use cases, with real life testing and stuff, we don't want agents to agree easily with each other. They need to dive deeper to find the better solution, to not to just very easily make compromise and find an agreement. No, they should kind of perfectionize their solutions to make sure that it covers all the cases and all the desires from all the parties. Also, what would be really cool to see is that the agents are a bit more autonomous and asynchronous. Right now, they actually behave according to how we define them in the environment. So if you remember, we have our, let me go back to the definition of our agents. So we have Ray, then we have Maya, and then we have Ethan. And the conversation always will go that Ray will tell their opinion first, then Maya, then Ethan. This is quite problematic for a couple of reasons. First of all, it's not reflecting how humans talk to each other. And secondly, whoever starts conversations between the agents will direct or will influence significantly the rest of the conversation. I have seen this quite well when creating that Mafia game, because if Mafia starts the conversation, Mafia wins. If villagers start the conversation, they have a good chance to overcome Mafia. So here we want to kind of mix the stuff a bit, make it a bit more reflecting the real life, where we actually sometimes interrupt each other, sometimes we talk in different order, sometimes we have more thoughts and we actually give more information. It's not really equally divided stuff between people, and we try to convince each other. The goal is not to agree, the goal is to agree in the group of people, but we also have our own let's say agenda and our own goals, and we want to achieve our own goals. And here what I have seen, the agents were totally fine with agreeing whatever was suggested, and then they didn't fight for their own needs. I mean, agents might not really have needs. Also, what I would want to see is that we don't have to give that goal, that mission step by step, because here, for example, we have the conversation first, and then as an additional task, we tell our agents to compose the guidelines for desk decorations based on the ideas given. I would like to see that the agents can actually come up with that idea and provide some outcome, some output based on that conversation themselves, but they are not really need us to dictate this, to micromanage their work. So that would be way more impressive. And as I mentioned, they're not really asynchronous, they're part of the single process. Would be really cool to see some kind of, I don't know, like pops-ups when they can interact and they can be asynchronous, and they can produce more messages, and there is not truly like this one process with predefined steps within that process. With all that said, I really enjoyed playing with this library. And I'm going to dive deeper here to understand more nuances and maybe borrowing some of those ideas. And I will be keeping an eye on where it will go in the future. I'm a JavaScript developer, so I don't think anyone wants me to contribute into Python code, but who knows, let's see.